Recently, scientists have successfully studied Einsteinium for the first time in decades. It is one of the most elusive and heaviest elements on the periodic table. The US Department of Energy first discovered Einsteinium in 1952 in the fallout of the first hydrogen bomb test. The element does not occur naturally on Earth and can only be produced in microscopic quantities using specialized nuclear reactors. Einsteinium is hard to separate from other metals. It is highly radioactive and rapidly decays, making it extremely difficult to study. As always guys, please remember to like, subscribe, and follow me on Instagram and TikTok for more videos just like these. Let's get straight into it. The element was recently observed by a Berkeley lab. They had less than 250 nanograms of the element. That's a very small weight, equal to about this many pounds. Einsteinium is made by bombarding a target element, in this case curium, with neutrons and protons to create heavier elements. The team used a specialized nuclear reactor at the Oak Ridge National Laboratory in Tennessee, one of the few places in the world where Einsteinium can be made. However, the reaction is designed to make californium, which is a commercially important element used in nuclear power plants, and so californium makes only a very small amount of Einsteinium as a byproduct. Extracting a pure sample of Einsteinium from californium is challenging because of similarities between the two elements. After extracting Einsteinium from californium, the researchers ended up with only a tiny sample of Einsteinium-254, which is one of the most stable isotopes or versions of the elusive element. Scientists cannot see Einsteinium. Instead, you can only tell the element is present from its radioactive signal. However, getting the Einsteinium is only half the battle. The next problem is finding a place to keep it. Einsteinium-254 has a half-life of 276 days, which is the time it takes for half of the material to decay. If Einsteinium decays, it breaks down into berkelium-250, which emits highly damaging gamma radiation. However, the element's decay also created another problem. Einsteinium is decaying constantly, so you lose 7.2% of the already minuscule mass every month when you study it. With that small amount of Einsteinium, they measured the Einsteinium bond length, which is the average distance between two bonded atoms. This is a fundamental chemical property that helps scientists predict how Einsteinium will interact with other elements. The more we understand about Einsteinium's chemical behavior, the more we can apply this understanding for the development of new materials or new technologies, not necessarily just with Einsteinium, but with the rest of the actinides too. With this information, we can establish trends in the periodic table. The methods established in this study set the framework for the discovery of more elements.